use them. So you didn't know how to use them. So the most important thing is you have all the formulas at the end of the exam and you will provided by the formulas. The main thing is to understand the concept and where it going to apply. You need to learn that, and for that you need practice. So we learn many times lectures, we we revise lectures, but we won't solve many problems. So exam is all about problems, so you need to solve as much as a problem to get a feel of the exam. So what people do mostly before the exam, they revise their lecture notes many time, but they don't practice problems which is related to the exam. So I advise you, if you have exam or pass exam on the blackboard, do practice that exam. And the first thing we're going to start, you have many questions. If you have if you have 24% of your exam is your then then it will having 24 questions in your exam. So there are five to six questions that are very basic in nature, that you don't require any kind of calculations. Five to six questions, maybe seven, eight, just the concept questions. Okay. For example, in this we have question number two. Which of the following is an example
Doctor,
of a? Yeah,
Doctor, this recording session, will it be shared so we can watch it again or no?
yeah, yeah.
Okay, thank you.
Okay. So five to six questions that will be only related to the concept or the just the definition kind of question. Maybe more, seven, eight questions. For example, this is the second question. Which of the following is an example of a scalar quantity? So velocity, volume, force, and none of these. So force is also a vector quantity. Velocity is also a vector quantity. And none is nothing. So we left with this. So this is volume. Okay. So here are many questions like this, like this, that you that you that you can have on your exam. So first identify that particular kind of questions so that you will be easy. Like for example, if you see which of the following is a fundamental physical quantity, so there are only seven physical quantities, that temperature, mass, length, or we have electric current, then these. So none of these is the fundamental quantity, because area is length multiplied by length, velocity is distance divided by time, and force is the your mass time the acceleration. So in these kind of questions you don't require any calculation type of question. So figure out these questions, that is the concept base or definition based. So figure out these questions and we will see how many types of questions were there. So if you see this question, for example, how many significant figures are there in this number? So if you know the rules of significant figures, that the point, the zero before this is not a significant figure, and these zeros are not significant figures as well. So these are not significant figures. So these three numbers could be significant figures. So 102 has how many significant figures? 1, 2, and 3. So here we have three significant figures. Okay, so figure out in the exam how many questions are these kind of type. So this is your type 1 question to figure out your exam. Type 1, which is concept based and definition based, which don't require any kind of calculations. And there will be many more questions you will find in your exam like this. Now, this is a type of question. Question number 4 is very simple. In very simple in that sense. What it requires minimal calculations. Minimal calculations. Just conversion or putting values into the formula. Okay, so a race car is moving with this speed 72 kilometer per hour. How many meters it travel in 1 second? So we need to convert this kilometer into 1 hour. So 1 kilometer is nothing but 1000 meter, and 1 hour contain how many seconds? 60 minutes and 60 seconds, which is equals to 3600.
3,600.
Yeah, 3600. So 72 multiplied by 1000 kilometer divided by 3600. So you will get 20 will be 20, so 1 and 2, so which you get 20 meter per second.
It's 20
Okay,
meters, yes.
so it's option C. Now question number 5 is again a conceptual question. So an object moves from point A to B following the dashed path, following the dash path. The magnitude, the magnitude of the displacement, magnitude. So what is distance and displacement? So it can move from like from point A to B over here, or it can move from here to B. So the shortest distance is your displacement, and the length of the path is your distance. So he is asking you the magnitude of the displacement. So displacement is always shorter than the distance. So displacement is always shorter than the distance. So you have is smaller than the distance.
Doctor,
Okay,
what if the distance is the same as the displacement?
distance, then it has to be moved into the same path.
So, oh, okay, okay, yes, yes, I understood.
Okay,
Yes,
it means they are moving on the same path. Okay, so it
yes,
can go from here to B, it's covering, but the shortest distance between the 2 points is known as the displacement, and displacement is a vector quantity and distance is a scalar
is
quantity.
a scalar quantity. Yes,
Okay, this is the difference as well, both measured in meters. Meters there are units, but they have a displacement has a direction, and meters or scalar don't have any direction, they require only number. For example, if the particle is moving from point A to B, the displacement has to be in this direction, and for a distance it could be any direction because it doesn't require any number, you can move any direction. So the length of the distance would be always, displacement will be always be smaller than the distance. So the next question is the vectors A, B, C. Okay, so to add a vectors, you have a rule, what we call right right hand rule. So what right hand rule says to you? Right hand rule says to you that head of the first vector, your vector head, and then you connected with this vector with the tail, or you can say it's tail. This is vector A, this is vector B or C, and this is your third vector. So tail will be tail and head will be head. So where head will be head is meeting, this means this vector is your resultant vector. So in that case, we need to identify at which point, the vectors having head and head over there. So this is how we add two vectors. So A plus C. So vector A plus C, vector A head, then the tail, and then head with head, you will get the head to tail rule. So you need to apply head to tail rule to get these kind of questions. If you have a diagram like this, always apply right hand rule or right hand rule or head to tail rule. Sorry, head to tail rule. It is head to tail rule. Head to tail. First vector head, then second vector tail, and the last vector both head will meet with the head. Okay. Now question number 7. So question question number 7
So,
is relate.
doctor, the answer for question 6 is D, right?
Yeah.
Yes.
Anyone is coming? Okay. 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 So now the question number 7 is a is multiplying with the j and giving you the 1, and here is the dot product, and dot product between two vectors like I dot I will always give you 1, j dot j will always give you 1, and k dot k will always give you 1, and then I dot j will give you 0, I dot k will give you 0, and j dot k will give you 0. So only I with the I give you 1. Now in that case over here you have j. So what a would have? A has to be
J.
Also J.
j.
Also
Yeah,
J.
j. So j, then it will give you 1. Okay.
Yeah.
So
Yes.
Yes.
now, okay, next move to the next question, and which is related to the
Doctor,
dot product.
Doctor, doctor, the type one questions. Will most questions be like this in the midterm?
Yeah, yeah, yeah. So it's a midterm exam of spring March 2023. So exam will be like this. There will be some type 1 question. This is type 2 question. Type 2 question. This is also a type 1 question. This is also a type 1 question. And this is type 2 question, minimal calculations. Now we are moving towards another question, which is
Doctor, some
question
people are
number.
asking if question 6, doctor, they're saying,
Yeah,
doesn't negative B mean that it's inverted?
yeah, inverted means.
So, question D is still the answer, right?
Yeah,
Okay.
this diagram somewhat ambiguous, because if we want an exact diagram, then we have to draw a coordinate system. This is your x, this is your y, this is your negative x, and this is your negative y. So in each direction, this is positive and this is negative. Okay.
Yes.
So this is also
Yes.
negative and this is this. So we need to decide in which direction this is going. But apply this rule. If you don't have anything, apply this rule: head to tail. Head to tail. First vector head, second vector tail, and the third is also give you the result.
Because,
Okay.
doctor, some people think that the answer is A.
It could be. I'm not sure about this ambiguous question, because if you see this, C will be negative A will negative B. So you cannot answer in any of the following where to decide your coordinate system. If it is your coordinate system, then these are all positive. Is this your coordinate system? Then this all would be positive.
Oh, doctor, I
So
think I think I think I figured it out. So, because it gave us the equation A plus C,
yeah,
we need to
Yeah.
add a plus c in the head
Mhm.
to tail method,
Head to tail
but b
rule.
is
So
negative,
I
so
always
the tail,
apply.
so the head has to be with the head.
Yeah. So I always apply like this rule, head to tail rule, to give my answer. Okay.
Yes.
Okay. Now move to the next question, which is rather uh, two vectors. So A, E, and D, the angle between two vectors. So angle between two vectors. There are, for example, there is, if there is a components of the vectors given, the two components like AX or AY. If two components were given, then you can find the angle theta with AY over AX, or theta will be tan inverse AY over AX. Let me, where are the other people? Okay. So you can find the theta as well. Now the vector two vectors given, and this is a component X, this is Y, this is Z component. So how do we find an angle in that situation? If you are given only two components like AX and AY, use this formula. But if you don't have this, this, this kind of vector, that is many components are given, then always use dot product. So dot product equation is E dot D. E dot D is E magnitude,
E d
D
magnitude
magnitude, and the cos of
cosine.
theta. Okay. So cosine of theta is nothing but E dot D divided by E magnitude, D magnitude. Okay. And theta will be cos inverse E dot D, E magnitude, D magnitude. Okay. So when, how to find the dot product E dot D? So many people are waiting. I'm not, how to add them in a meeting. Yes, that's the problem. Okay. Details. Apps. So I'm not sure. Is it a message or uh, people are waiting?
No, no, no. When
Okay.
people join, it makes that sound.
Okay. Then how to add them? I'm not getting used to it. Such meeting going. I'm not. Let's. Okay.
Doctor,
So
people have some concerns about question five, I think.
question
They
five.
say no, no, six, doctor. They're confused if it's A or D.
Um, because we cannot decide with this ambiguous figure. So question five is rather question like six is rather ambiguous in that kind, because
No,
diagram
doctor, I will
properly.
try to explain, doctor.
Okay.
Um, Doctor, so I think it's D because A plus C, it's in the head to tail method,
Yeah.
but B is not. It is
In the
not in the
negative
head or
direction.
tail method with A. Yeah, it is in the, like the, it's like flipped عقورة بعض الناس في الشات.
Yeah.
So like because it's like flipped, it's not head to tail. It's like tail to tail or head to head. I think
Yeah.
that's what makes it like negative, right?
Yeah.
Also, doctor, it's not A because look at the arrows. All of them are head to
Yeah.
tail. All of them are.
Yeah.
It's basically A would be A plus B equals C because all of them
Yeah.
are attached. None of them are.
Yeah.
The
Yeah. Yeah.
bo-
Yeah.
the
Yeah.
Yeah.
So in that kind of diagram, you cannot decide which is the correct answer. So I rather apply head to tail rule to guess these things.
It's easy to make mistakes in that question, doctor.
Yeah, yeah.
I don't know.
Okay, let's move to the next question we were doing. So so the question is E dot D. So how to find a dot product of E and D? So E and D. So here we have, for example, we learn that I dot I is 1, J dot J is 1, K dot K is 1, and I dot J is equals to 0, J dot K is equals to 0, and J dot K is equals to 0. Okay. So
Yes.
over here now, over here, you see that. So we can find this is I dot I. So you will get 6 multiplied by 5, 30, I dot I1. Then 4 multiplied
Yes.
by minus 6, then you will get 24. And then 2 multiplied by minus 2 multiplied by minus 3, which we get 6. So this
Positive
is the
6.
dot product. Yeah. So this is the dot product. This is the dot product of this. So 30 minus, which we'll get 12. Okay. Now, how to
Mm.
find the magnitude of D and E? So if you have the magnitude of this, if you have the magnitude D, so D is square root 5 square plus negative 6 squared plus negative 3 squared. So this is how you find the magnitude of any vector. So with the magnitude of this is 7.48. And similarly, you will find the magnitude of this, which is 8.37. So when we substitute the values over here and calculate the angle, which is E dot E is 12, and then we calculate 7.48, and then we have 8.37, and then cos inverse. So you take the angle, you will get 79 degree. So this is how you
Doctor,
find
it's not inverse
the,
tan?
no, 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 it's not inverse tan because it has many components. If you are given only X component or Y component, then you use that formula. Okay. If you have many
Yes.
component form of vectors like X, Y, Z, use this always.
So
Okay.
cosine. We use negative cosine.
Negative cos inverse,
Inverse
yeah,
cosine.
inverse cosine, and find this value
Yes.
E dot D and E dot D. And this is your type
Yes.
3 question, which
So it requires a
require
bit more calculations.
calculations. Okay.
Yes.
Now, next, over the period of time, the acceleration of the particle is 0. And this means that
Velocity is constant.
velocity is constant. When velocity is
Constant.
constant,
Yes, doctor.
because so acceleration is dv dt. So
Yeah,
acceleration
doctor.
of the card is 0. So dv dt is 0. So v is constant.
Yes, doctor. If they are both zero, if that makes it constant.
Both 0 means,
Means that it will be constant because if the acceleration is zero, then the
yeah.
angle will
If
be equal to zero.
for example, if we have an object at rest, its velocity is 0,
Velocity is 0.
its acceleration is
Therefore, the
0 as well.
acceleration is 0.
Okay. So these
Yes.
two are the, but is not always the case. If the body is moving with constant velocity, like constant velocity of 45 miles per hour, then its acceleration is 0, but velocity is not 0. And this is the explicitly conditions over there. So velocity is constant, it means the acceleration is 0. The derivative of the velocity is 0 because it's a number always.
Yes.
Getting my point?
في حد ما فهم؟
Okay.
clear دكتور.
Okay. Now move. This is only the type 1
لكن
question as well.
صعب الموضوع هو.
ها
يصعب الموضوع.
yeah
واضح
doctor
لي.
in that question I don't think we still went to the derivative and the I just
No,
think
no.
that it's like a basic knowledge that if
Yeah, yeah, yeah,
velocity is
yeah, yeah.
constant therefore
Yeah.
acceleration is zero, right?
Yeah, yeah. I'm
Yes.
just explaining to you the other side of this as well.
Yeah.
Okay.
Yes.
Now, the figure shows the position of the object as a function of time, during which time interval the object is at rest. So, what, for example, I give you the options A, B, C, in which you think that the object is at rest.
uh B.
B, because it's a straight line. In that A, the it is increasing.
Accelerating.
Okay, accelerating. Yeah. In that case, C, it is decelerating.
Decreasing.
And yeah,
Yes.
in that case, it's it's rest or moving with uniform velocity. It could be. Okay. So
Yes.
if you see this diagram, so you will see this part and this part which lie between 3 and 6. 3 and 6. Okay. So
Yes.
your answer is 3 and 6, at which the object is at rest.
Yes.
Okay. Did you get that?
Type 1.
Yeah.
Yes.
Now move to the next question. An object is moving in a straight line. The graph shows the object's position as a function of time. What is the displacement of the object in time interval 0 to 4 seconds? 0 to 4. It starts from here and it wants us to calculate the displacement over here. So displacement, how do we calculate displacement? Is the position at
Shortest route.
different spaces. So R2 minus R1, or if we have in one dimension, x2 minus x1. These are the position. So what is the initial position? 0. What is the final position? 4.
4.
Okay.
4 minus 0.
Okay. Yeah. So now,
Yes.
no, this is the time axis. He wants the position. So
Oh, okay.
time
10 minus
is
0.
4. So 0 and the position at this point is 10. So you will get 10 minus 0, which is 10. So your answer is, this is type 2 question. Okay. Now a ball is thrown straight up with the speed, straight up. How long does it take to reach the maximum height? Always remember, when it reaches to the maximum height, its velocity goes to 0. Which velocity? This velocity is given and this velocity is given. So this is your initial velocity and this is your final velocity. Okay. And the object is falling under the action of gravity. So we're going to write a equation that is free fall. So equation is v no vy is v naught of y minus gt. So vy is 0, v naught y is 30, g, because it's going up against the gravity, so g is negative. Okay, so g is negative, so which is 9.8, and time we need to find. So t will be 9.8 equals to 30. So t will be 30 divided by 9.8. So 30 divided by 9.8 is what?
It will be
3.06 seconds.
3.06.
Yeah,
Let's see.
so it's C. Okay, and this is your type 2 question. Are you getting my point now? Okay, now The coordinate of x of a particle in meters is this, where where the time t is in seconds, the particle is momentarily at rest, which means its velocity goes to 0. When the object is at rest, its velocity goes to 0. So how do we find velocity by a function of x? Anyone?
Derivative.
We do
Okay, so
derivative.
we took the derivative. So how to take a derivative? It is v is dx by dt. So derivative of this function is 16 minus 9 t squared. Just using the power rule. So velocity is 0. So 16 minus 9 t squared. So 9t squared equals to 16. So t squared is equals to 16 by 9. And t is 16 9 square root, plus or minus two values. So time will be always positive. It moves in the forward direction. So we will get only the positive value, which is 16.9. And when we solve this 16.9, we will get 1.33.
It's 1.33.
Yeah. So this is the correct option. Okay. This is your type 2 question as well. Now, next question. Which of the following is obtained by dividing the total displacement divided by the total time? It's a definition type question. So what is this? A, B, C, D.
D.
It's the average velocity.
Average velocity, because it is displacement. If it is distance, then it has to be average speed. So
Speed.
in that case, your option is D. If there is a total distance divided by total time, it has to be average speed. Average speed is a scalar quantity and average velocity is a vector quantity. Okay, let's move to the next question. A man walks south at speed of 2 meter per second for 15 minutes. He then turns around and walks at north 200 meter and in 15 minutes. What is the average velocity of the man during the entire motion? So average velocity is your total displacement divided by the total time. So it moves through south and then move towards north and south. So for this, how to calculate distance? This is d1 and this is your d2. Okay, so in 15 minutes and in 15 minutes. So d1 we will calculate by s equals to vt. You know that v is your velocity and t is time. Over here, which is given 2 multiplied by 15 minutes, 2 multiplied by 15 multiplied by 60. Okay, because in minutes is seconds, which we will get 1800 meters. And d2 we have 2000 meters. And the total time, how to find the displacement? Displacement d is, how to find displacement? d2 minus d1. And what is the total time? The total time is 15 minutes plus 15 minutes. So total time is 30 multiplied by 60, which is 1800 seconds. And your displacement d2 minus d1 is nothing but 200 meters. 2000 minus 1800, which is 200 meters. So what is your average velocity? Is total displacement d divided by total time. So you will get 200 divided by 1800, which is 0.1 meter per second. So the option B is correct. Okay.
Wait, doctor, can you go
This,
back? Wait, can you go back?
yeah, yeah, yeah.
Why did we have to convert the minutes to seconds?
If you see this, all the units are given in meter per second.
Okay, I
Okay.
get it. Okay, sorry.
It's okay. It's okay. No problem. Now, this is your type 3 question. For a journal projectile, the magnitude of the horizontal component of the projectile velocity, horizontal. So if the projectile is moved like this, always its vertical component is changing and the horizontal component always remains the same. So horizontal component remains the same, which means C is the correct option. So this is a type 1 question. Are you getting my point? How many questions are there in type 1? So this is you need to identify. So do these questions first and then move to type 2 and then move to the type 3 to get out of the maximum things. Okay, so the range of the projectile motion will be maximum. So range of the projectile has a formula which is R, I think VI sine 2 theta over G, VI. This is the initial velocity and you have sine 2 theta. So what angle this sine will become maximum? Sine will become maximum at 90 degree. So what we angle we put over here, multiply with the 2, it will become maximum. So the range of the projectile always maximum at 45 degree. Okay. Now, question number 18. This is your type 2 question as well. A particle is moving in a circular path with radius 1. At what point A is moving with the speed this v meter per second and increasing at the rate this. So what is the radial acceleration? So the radial acceleration is nothing but v square over r. So what is v in that case, which is 2 and r is 1. So just substitute the value. We will get 4 meter per second. So the radial acceleration is 4 meter per second square. This is type 2 question. Next question. A particle starts from the origin. Starts from the origin. This is the information. When the object starts from the some point, its initial velocity is always 0. Okay. Okay. At t equals to 0. Starts from the origin. If it's rest, there is no point here is the rest. So it starts from the origin with the velocity. It means it has a velocity, which is the initial velocity, and moves in xy plane. So it's moving like in xy plane. This is x and y with a constant acceleration. This is the acceleration. At instant that the particle achieved maximum positive x coordinate. So when it achieves the maximum x, how far is it from the origin? How far is it from the origin? So we need to calculate the x and y. So how to calculate x is nothing but v naught of x t plus 1 half a t squared. And how to calculate y is v naught y plus 1 half a t squared. Ax, ay. So if you see this, if you see this initial velocity, okay, so it has only 6i, which means It has only the x component.
X
So this
component.
is v component. So what is vy in that case? Vy
0.
is 0.
Zero.
Yeah, 0. Okay. So Vy is 0. So at what maximum point it can go? When at a maximum point, we can say that at the point when this is V naught, its maximum velocity goes to 0. Then we can calculate the time, which is Vx is V naught of x minus gt. And then we substitute over here, we substitute over here, and we get t equals to 3 seconds. So now we have t 3 seconds, and we have v naught of y, and we have ax, which is this ax, and this is ay. And when we substitute the value v naught of x t plus 1 half ax is minus 2, and ay is 4. So we will get x equals to 9 meter. This is the x displacement, and y is 18 meters. And what is asking is the achieves the maximum positive. How far it goes from the origin. So you need to find the distance. So how to find the distance if it's in xy plane is nothing but x square plus y square. So just substitute the value 9 square plus 18 squared is,
It will give 20.1.
yeah, 20.1. So your answer is 20.1. This is your type 3 question. Okay, let's move to another question. Question number 20. The acceleration, the velocity and acceleration of the object in a certain instant of interval is this. V is 3I and acceleration is 5. At this instance, the object. So this is type 1 question. Velocity is positive and acceleration is positive. It means they are speeding up
Speeding up.
and moving in a,
And moving in a straight
Straight.
line.
yeah, moving in a straight line. So speeding up and moving in a straight line. Great. Now the projectile motion. Next question. So a man stands on the roof of the tall building height h and throws a rock with the speed 29 meter per second. So this is your initial velocity, which is v naught of y with an angle theta. The rock strikes the ground at time 6 seconds. This is your time after thrown. Ignore air resistance. Find the height of the building. So we have initial velocity v naught of y, which is v naught sine of theta. This is your v naught sine of theta, which is nothing but 29 sine 30 degree. If I ask you what is the horizontal component of the velocity, what will be?
Doctor, what is the value of the V naught?
V naught
0.
is
Velocity for the
0.
0.
Yeah, yeah,
Yeah.
0. And it's 14.5.
Doctor, you have you have the sine and cosine.
Sorry?
You have the sine and cosine. The velocity.
Yeah, sine. Because we are in projectile, we are talking about y component. So when you have a vector, it has
Doctor,
two
why
components.
sine and cosine?
Because we have two components. This is y component and this is x component. So x component is ax is a cosine theta and ay is a sine theta. So we are considering y because it's moving in this direction. Okay. So y, so in projectile, we always consider the y component of the velocity and x component of the velocity remains constant. Okay, that's why we are taking sine theta. So now we need to find the y, the height of this object, which is h is v naught of y t negative 1 half gt squared. So we have v naught of y over here, t over here, 1 half, g is 9.81 and t is 6 seconds. When we substitute the value, we will get 89.4, which is closest to 89. So this is your type 3 question as well. Next question 22. So a flat car is traveling to a distance to a right at a speed of 13 meters per second. Flat car. Relative to an observer standing on the ground. This is the observer. Someone is riding a motor scooter on a flat car like this. If the velocity of the scooter is relative to the observer to the ground is 18 meter per second, what is the magnitude of the velocity of the motors relative to the flat car? So according to this observer, this is moving with 13 meter per second and this is moving with 18 meter per second. So if we want to find the velocity of the scooter with respect to this, we need to subtract the value. So what will be the subtraction? 18
5.
minus 13, which is 5
5.
meter per second. Okay, type 2 question. So what is Newton's law?
Wait,
Question number
doctor,
2.
can you go back up? Wait, doctor,
Yeah,
can you go back up? Uh,
yeah.
okay, so why do you have to minus it again? Like,
Because
why?
of this velocity. If we talking about the observer, then the v scooter plus v flat car. But if we talk about what is the speed of this scooter with respect to this flat car, which is moving with 13 velocity, 13 meter per second. So it has to be a difference. If we are moving with the observer, this is the condition. Because what is the magnitude of velocity of the motor scooter relative to the flat car?
Okay, doctor.
So what is Newton's second law? Force time, force equals to mass time acceleration, which is a force over. So option, which option is correct?
Last one.
B, D,
E.
D, doctor.
Hmm?
Last,
D.
last one, last one, last one.
Yeah. So this is the correct option. So now this. So an apple sits at the rest on the table in equilibrium if the normal force is the action is the action on the apple, the reaction is. So here we apply Newton third law. Every action has equal and opposite reaction. So normal force. So when you are standing on the ground, you push with a force and earth will push you further up. So here is your action and here is the reaction. So what is the question? If an apple sits at the rest on the table in the equilibrium, if the normal force is this, which is the table exerting on the apple. So what is the reaction in that case? What is
B.
the reaction? Hmm?
The
It's
force
be
of the
the
atom on the table.
Yeah,
Yes.
the force Apple exerted on the table. So this is the pair. Okay. So this force act in pairs. So this is the action or this is the reaction. If this is the action, this is the reaction. In both cases are true. Okay. So the force of Apple exerted on the table is the reaction of the normal force. Question number 25. Two forces F1, F2 acts on an object of mass this. So the magnitude of the object acceleration is. So if you are given this force and it's in the x direction and this in the y direction, if we consider the coordinate system over here, this is your x, this is your y. So now to get the total force, which is the net force, is nothing but to calculate the magnitude of this force, which is nothing but fx squared fy squared. So f1 is your fx and f2 is your fy. So when we substitute the value of f1 and f2, fx and fy, we will get the magnitude, which is the net force. So the net force is 25 Newton. Just 20 squared and 15 squared, you will get 625. And when you square root 25. Now the mass, the magnitude of the acceleration. So it says that sum of all forces equals to the mass time acceleration. And this is your net force. So your net force is 25, mass is 5, acceleration. So acceleration is 25 over 5. This is your 5 meter per second squared. This is type 2 as well. So name the missing force. Gravity is the action. This is normal force is the reaction. And the friction, fast moving object is moving with the velocity. What is this force? Which
Applied
always
force.
act in the opposite. Which always act opposite.
the
Friction.
friction force. The
Yeah.
friction
So
force.
friction force always opposite to the driving force. Okay.
But doctor,
Yeah.
I think if and the F is already there, the friction force,
Yeah.
no?
If F, yeah, you are right. Now F is already there. This is friction. And now
It's
this is the
B.
applied force.
Yes.
Applied.
Applied force. Yeah. Now the next question is a block of weight 75 Newton on Earth. If the acceleration due to gravity of the moon is 1.62, the weight of the block on the moon. How to find the weight? W is equals to
mg.
mg. Simple. So 1.75 multiplied by 1.62, which is 12.4 Newton. So if we measure this mass on Earth, this is how much the weight. 75, 9.81. Now to the next question, 28. So this is an important question because you will find these type of question in the exam as well. So the horizontal surface on which the object slides is frictionless. It means you eliminate frictional force. It's going to be zero. If the mass of 1 kilogram and the magnitude of the force of small block on the large block is 5.2, which is the contact force between two, which is the contact force on that these two. So what he is asking you, determine the total force that is that is the applied force on it. So if this force is 5.2, it means it's moving this object with a mass of 1 kilogram. So what is the acceleration? So acceleration is F divided by mass. So acceleration is 5.2 divided by 1, which is 5.2 meter per second. So what is now the total force? Total net force, which is nothing but the sum of these two masses. Sum of these two masses. Mass of small, mass of small plus mass of large times the acceleration. So what is this contact force between them? So 5.2, then the mass of small, and then you will get the force, which is 7.8 Newton.
Doctor, some people have question about question 27.
27 what? What question? Is it in the chat? Okay.
Yes.
What question? What mass did you get to A? Question 27. Okay. So question 27 is this. Okay. Yeah. Okay. So the weight is W, which is mg. So m is W divided by 9.81, which is g. So 75 divided by 9.81. So we will get in that case mass 75.9.81. So you will get the value, and then you substitute that value, then you will get your answer with the weight over here. Is it clear now? Hmm?
Yes.
Doctor, doctor, I just want to ask you, where will you send the recording to us? Where will you send it? Will you send it on email or where exactly?
Okay, I'll send it to your the maybe the instructor or the course coordinator, and I will upload on my channel as well, from where you can get these. I have many more videos like this as well over there. So like I teach this course last summer, so there are so many videos are there as well, so you can have. I can share the link. Ever heard?
Yeah, doctor,
I
can you
can.
share the link? Yeah.
So I will share the link over here in the chat so that you can uh, access as well.
But doctor, can you also share
Yeah,
the solved file you just told?
Yeah. I send it to your instructor, and he will upload it on the Blackboard as well.
No problem.
Okay.
okay. Thank you, doctor, because I have to leave now. Thank you.
Okay, no problem.
Can you explain 28 again, doctor? 28, 8.
28, yeah. So 28 is to calculate the horizontal surface on which the object is the frictionless. So if mass is this, and the mass is 1 kilogram, m is 1 kilogram, and the magnitude of the force of the small block on the large block, is 5.2. So this is the contact force between two. So if we are applying a force, then this is the contact between them. Then we are applying a force on it, and then the body moves. So we need to calculate the acceleration than when the object is moving. So when the object is moving, we calculate acceleration with this, which is, sorry, a time the force divided by the mass, and then you will get the acceleration. And by the contact force, the total force is the sum of these two. So when you substitute the value of these two, you will get, and the acceleration is there, so you will get a total force which is 7.8 Newton. Next question is 29. So for an object sliding on a rough surface, the friction is, so what will be the friction? Friction is always a parallel force. So these two will be cancelled out. So always a parallel force. And it is always opposite to the direction of the velocity. So which option is the correct?
D.
It's D. So it is in the same direction. It is always in the opposite direction. So this is your type 1 question as well. For a uniform circular motion, the net force is always what? Net force is always what?
Zero, Doctor.
Radial, is always radial. So the question number 31. So a break of mass, a brick is resting on the rough inclined surface of the figure. The weight of the brick is the weight of the brick. So what will be the weight of the brick? Is greater or less? Because it could not
Equal.
be zero, it could not be equal. It has to be greater because it's moving.
Greater.
Let's say it is resting.
The brick is resting on the inclined plane. Yeah. And
Doctor,
he
if it's
asking
resting, it
you,
means it's not moving.
yeah, it's not moving. So then it is equals to the frictional force.
Yes, so B.
Yeah. So then next question is the 5 kilogram object is suspended by a string from the ceiling of an elevator that is accelerated towards at the rate of 2.6 meters per second. So what is the tension in the string? So what is the tension in the string? So how to calculate the tension in the string? So T is tension, is what? Mass due to gravity, and mass tension due to the acceleration. So T is mg minus a, which is g 9.8. So T is m 9.81 and acceleration is 2.6. So we will get 36 Newton. Should we stop over here, or we continue because the time is over? It's now
As you like.
7. Huh?
As you like.
Or we can
Just like 3 more questions.
Yeah, okay. Let's 3 more questions and do it. We'll finish. Okay. So now the two blocks are accelerated uh, across the horizontal frictionless surface as shown. frictional forces keep the two blocks from the sliding relative to each other, and the two blocks move with the frame acceleration. So F is and mass is 1 kilogram. What is the magnitude of the horizontal component of the force, frictional force? The large the block of the mass. So on the larger block, on the smaller block. So what is the frictional force that will be act on that? So if you know, frictional force is mu times the weight of the object. Okay, the force is given, which is 1.2. So the force is given, which is weight, is 1.2. And on the larger mass, the larger block, on the smaller block, it exert a force with this. So the force is 1.2 divided by 2, which is 0.6 Newton. So we get 0.6 Newton. Question number 34. Question number 34. A toy car of mass this at a constant speed inside the track of radius this. If the normal force exerted by the track of the car, then when is the top of the track is 6 Newton. Find the speed and speed of the car at this point. So the centripetal force is mv square over r. But what is the total force of this? This is the normal force plus the weight of the object, which is mv square over r. And we have normal force 6 Newton, and the mass weight we can get mg 0.5 0.8 multiplied by 9.81, and then we substitute the value. So we will get v, which is 9.3 meter per second.